Okay, so I'm only going to do record videos, video. I'm only going to include problems that don't have video attached to them. Okay, just because I don't know. I mean, it seems like double, double the effort if double. Why do it twice, right? So, all right. So here, let me get my board going here. And this one doesn't have a video. So question number 3. So they gave me the graph of this reciprocal function. That's shifted down 3, okay? And then now, and what they're asking, these aren't so much limits at infinity, these are infinite limits, because as I approach, so remember come on board, why aren't you working? I guess I can turn it on. Okay, so what we got to do is annotate, let me click annotate and spotlight, there we go. So is this working now? Okay. So as I approach -1 from the left, I'm going up to positive infinity. So I'd have to do, right? And then as I approach -1 from the right, I'm going up to positive infinity. So what is the limit as x approaches -1? Well, some people, there's 2 ways to do it. And I'm going to be very curious. I'm going to answer this and see what my math says. There's two ways of thought about this. Because both of these right-hand limits and left-hand limits are approaching infinity, we're going to say it's an infinite limit, so we can never get there. It doesn't exist. Then some other people say, hey, they're both approaching the same value, some big positive number. So yeah, it exists. It's that big positive number. And of course, let's see. Let me see what it is. I'm gonna try it and see. So let's see. It goes to 00, and then it goes to 00. What? No, I did 00. One like that. 00. And then I'm going to try it. I'm going to take a risk and see. I think because it goes to infinity, I'm going to say positive. Let's see. But of course, f of -1 does not exist because it's a discontinuity there. It's infinite discontinuity. Let's see if it likes it. Oh, it did take the infinity. Okay. What did they say here? Did they say or? Yeah, no, they said infinity. Okay, so when your left-hand limit approaches your same as your right-hand limit, the limit exists. That's something we did way back in week 1. Okay, so there's that one. Let's see here. What else is there? Okay, does this have a video? Yep, that has a video. Here, I'm going to pause this video so you don't have to watch me flipping through these. Okay, so for question 5 does have a video, but it's a fairly long video with a lot of different kinds of limits in it. So I mean, I might be worth your time to watch it, but how, and they don't do anything too awfully complicated. Actually, they don't do much more than what I'm going to show you, but at least this is specific to this problem. So remember, when we go out, if you've watched my video about this, as we go out to infinity or out to negative infinity, the -1 doesn't matter, the 7 doesn't matter, even the 3x doesn't matter underneath here, but I'm keeping the leading, notice I'm keeping the leading terms. So I've got the square, so what I'm going to worry about is the square root of 36x squared and -4x. Now, if I take the square root of the numerator, that leaves me 6x over -4x. Now, I could certainly cancel those out. However, we also got to pay attention to the signs is going on. So as I go way out, so really what I've done here, when I take a square root, I'm always going to have a positive answer here. Unless it's like, if it's x squared equals 36x or 36, then I'd have to worry about plus or minus 6 because both those numbers squared. But I've already taken the square root, so I only got to worry about the positive one, right? So really, I'm looking at the absolute value of that answer. So that means the numerator is always positive. The denominator has that -4. So whatever x gets plugged into, it gets multiplied by -4. So as x goes out to positive infinity, this will always be a positive number. -4 times a positive number means the answer is negative. So this really becomes 6 over -4, which is -3/2. So that's why that's the limit. Okay. Now, conversely, when we go out to negative infinity, that's going to become a negative number. Negative times a positive, negative times a negative is a positive. That turns the limit to positive 3/2. And then, of course, they're looking for the equation. Well, these do approach limits. I mean, the limit, you know, it does approach a value. It said it doesn't go out to infinity. So that means it's a horizontal line. The horizontal asymptotes are y equals, remember, all horizontal lines are y equals some constant number. So that's why they are looking for it like that. Okay, so hopefully that helps. Pretty straightforward question. This video will certainly do it for you. Okay, and again, if you get stuck with it, you can come see me, or you know, post it in the discussion forum. Be great to help you out. Somebody can. Okay, no video here. So, but again, it's a pretty straightforward question. So we're going to do the derivative. So f prime of x equals 4x cubed minus 32. And then this is a polynomial. So there's no places where the derivative will be undefined, but there will be places, well, there probably will be places where it's x cubed in x cubed, not cubed, x cubed minus 32, say it was equal to 0. So that's going to give me, I'm going to add 32 divided by 4, I get 8. And then I'm taking the cube root. So x the cube root of 8 is 2. And that's all there. There's only answer. So there's only one critical point. So I'm going to do that first derivative test. I'm going to drop in, I'm going to put 2 in. Here's my derivative. Sometimes I think what I'm going to do here is I think I'm going to write this as 4 times x cubed minus 8, just to make my work a little easier. So if I go left of 2, like 0, isn't that going to be a negative number? That means the derivative is negative. And if I go right of 2, that's going to be a bigger number. So it's going to be bigger than 8, so it'll be positive. So I know that this function's decreasing from negative infinity until 2, and it's an open interval on both, and it's increasing from 2 to infinity. And I mean, we know it's a fourth degree equation, so we know the ending behavior is going to look something like this, right? I mean, yes, there's some wiggles going on, and without having to do more work, and they aren't asking us to. So see how it goes up that way. Now let's go see what let's see. So I've got my 2 answers. F of x has a, oh, then we got to ask whether it's a minimum or maximum. Okay, here we go. Because the derivative is changing from a negative to a positive, or the function is changing from a decreasing function to an increasing function at x equals 2. That means it's a minimum, right? We know it's going to bottom out there. We know it's going to bottom out there at 2. You know, whatever else it does, we know it turns. It's a turning point there, and it's a minimum value. So let's see if I can get this right. Let's see here. So the critical point is at x equals 2. It's not looking for an ordered pair. We know it's increasing from 2 to infinity. We know it's decreasing from negative infinity to 2. And we know it has a minimum at x equals 2. Man, I almost didn't put that in. Let's see. Does it like it? Oh, yes. Okay, I've got a rational function. I got to do some work with it. So something I noticed right off the bat is that the numerator factors. So this is going to be fairly easy to graph. So that's what I did first off. No, I didn't use Desmos. I mean, well, I know if you use Desmos, no, but you know, you should try not to. So the numerator factors at x minus 1 times x minus 1. So that has a 0 at, so did I write anything down here? No, I would just here, I'll talk you through it. So I know it has a 0 at x equals 1, and it has multiplicity 2. So that means it bounces off the graph there. Okay. And then I'm sorry, I had this horizontal asymptote. I wasn't paying any attention. This was x squared till I started to graph. I went, oh crap. So I didn't erase it. So there's a mistake. So I just ignored it. So you can ignore it, okay? Because really I could have done all this without graphing it. So I didn't figure it was that big a deal. I wanted to find out when it crosses the y-axis. So I dropped in 0. So at 1, so I graphed that point and graphed that point. And then because it is a top heavy function, I decided to do the long division so I could find that slant asymptote, that oblique asymptote. So, I mean, I did that. And if you want, you can pause the video and write that down. So it came up that I had a slant asymptote of x minus 3 plus the remainder over the quotient, right? So I sketched in that dotted line, the slant asymptote x minus 3, right? And then I know it has to bounce off there. I knew it had to go through there. I knew this was a vertical asymptote. So that's how I knew it was sketched in like that. And then this has to be down in this corner because that's never going to cross. Well, it doesn't cross the y-axis. It also doesn't cross the x-axis, and I want to make sure it was still a function passes the vertical line test. Okay, so that's my graph. So I'm seeing a maximum here, a minimum here. I'm seeing increasing, decreasing, decreasing, increasing. So I kind of know where I'm going with this before I even start doing some calculus. So then I decided, well, this is the quotient rule, and you probably heard me complain enough times about I really detest the quotient rule. So I avoid it when I can. You can do it. You get the same answer, and if you feel comfortable doing it, don't feel bad. Don't think I understand. Sometimes I don't do that. So what I did is I took this form of it, and I took the derivative of that because that's pretty easy to take the derivative of. The derivative of x is 1 and 3 is 0. And then this is just 4 here. I better write this down, because if you were in my classroom, you would have seen me do this many times. And I'm not sure how much you have seen. So 4 times x plus 1 to the -1. And then that way I can just treat that as a power, bring the negative down in front, take away 1, then times the chain rule, right? Which is just 1. So that's how I got -4 over x plus 1 squared. Okay, so that's the derivative. Now they're going to make me do some work with this. So, I mean, like I got to figure out what are the critical values and when is it increasing, decreasing. So because I have it in this form is, let me get a pointer going. Having it in this form makes it hard to find zeros and all that. So what I did is I just multiplied by x plus 2, x plus 1 squared over 1 plus x plus 1 squared. That way I can combine this all over x plus 1. And then I needed to find out when is the numerator equal to 0. Now I could FOIL it all out and do it, but I could just extract the square roots, right? I could add 4 to both sides, take the square root, and remember plus or minus 2. Then I subtract 1. So the zeros are happening at x minus 3 and x equals 1. So, and then of course there's a critical value, right? X can't equal -1 because for class asymptote, so that makes it a critical value also. So on my number line, I marked it, this is f prime of x, what I'm doing. I marked in the -3, the -1, and the +1. But then I had to think about, now I got to go back and figure out when this is positive and negative, or when this is positive and negative. So what I did is I FOILed it out. I FOILed out the x plus 1 squared, and got that -4, which became that. And of course, then that factors that, which I kind of knew anyways because of the zeros, but so maybe it would have been easier to do the quotient rule to begin with. I don't know, though this was pretty quick. So then now I'm going to pick a number that's less than -3. So if it's less than -3, that'll be negative, that'll be negative. So a negative times a negative over a positive, because the denominator is always positive, that'll be a positive number. I pick a number between -3 and -1. Well, that will be positive because 3 is bigger, but that'll be negative there. So positive times a negative divided by that positive is negative. And then I'm going to pick a number between -1 and 1, which 0 works well. So positive, negative, positive, negative, positive, it's negative again. And then greater than 1, that's positive, everything's positive, it's all positive. So what I'm seeing is I'm seeing this function is increasing from negative infinity until negative 3 and from 1 to infinity, and it's decreasing between negative 3 and positive 1. Now it's a momentarily, I mean, there's a disjunction at negative 1, right? Because the vertical asymptote. So I'm thinking my open math's probably going to want me to say from negative 3 until negative 1 open interval, or from negative 1 to 1. Okay, because it's not actually decreasing here, right? Because I'm going to negative infinity and it jumps up to positive infinity. So we can't have it just say from negative 1 to 1, because that wouldn't be true. So we probably got to do the disjoint set there. And then because some other things, you remember how I said it looks like there's a maximum and minimum? Because at negative 3, the function is changing from an increasing function to a decreasing function. That's going to be a maximum, or the derivative changes from a positive or negative. That's a maximum, and it's a local max, right? A relative max. And then same thing, it's going from a decreasing function to an increasing function, from a derivative change from a negative to positive. That means that's a maximum. Of course, we knew that, and we knew that was happening at 1. Okay, now the only thing I haven't done, and I don't remember what the myope math, I didn't pay attention to the myope math problem enough. I didn't calculate y's. I might need to go back and find the y value for x equals negative 3. We'll see. Let's go back and see what myope math wants. So the critical points, I said, oh crap. Oh yeah, I get it on paper. Just a minute here. I scanned it. Let's see here. So my critical points were where? They were at negative 3, comma, negative 1, comma 1. Hopefully it likes all those. And it's increasing from negative infinity to negative 3. And then let me just do the U. Well, I don't know. I'll try it. Sometimes my math likes it. Sometimes it doesn't. No, it doesn't see it. Give that weird U. So I got to use the interval. Then from 1 is 1. Yeah, it's increasing from 1 to positive infinity. And then, separate them with U. Oh, good. They did say U. All right, good. And then decreasing is from, so again, this is where I got to use that disjoint set. So it's decreasing from negative 3, comma, negative 1. And then we'll click on the U, interval U, then from 1, negative 1, comma, until 1. I think that's right, right? Looking at my number line. Yeah, that was right. Okay. And then f of x has a minimum, it has a maximum at x equals negative 3, we said. And it has a minimum at x equals 1. Oh, what didn't it like? Oh, didn't like that. Are they telling me the negative 1's not a critical point? I mean, that could be the only issue. Yeah, that's what it's not liking. Technically, they're not right. Negative 1 is a critical point or critical value. And I mean, I know it's not defined on the function, but still it's something we had to test, and it certainly helped. If I hadn't had that negative 1 on my number line, I would have just said for decreasing from negative 3 to positive 1. What if I go back and let's go back and test my open math and let's see, what did they say the answer was? Yeah, see, they made the distinction that it's got to jump over negative 1. So see, I think that whoever wrote this problem messed up a little bit. Okay. Okay, another one without a video, and this is a weird function. I know there's some kind of linear, it's a product of a linear function and an exponential function. I have no idea what it looks like. But I don't really even need to know that because we've got calculus, right? So let's do the calculus. So I got to do the derivative, find the critical values, et cetera, et cetera. So here's what I did. I noticed, I said, boy, wouldn't it be easier? You know, product rule is okay, but let's try to avoid it if I can. It works out, I couldn't, but I did this anyway. So I distributed the e to the x through, and then the derivative of e to the x is e to the x, right? And the 3 is a constant multiple, and the chain rule, the x minus 3 is just 1. So that's the same derivative. And this one, I got a product going on, and you need to use the product rule. So I stuck the negative out in front, and I said first times the derivative of the second, plus the second times the derivative of x, which is 1. Then I distributed the negative through, and then I said, oh, some like terms, let's put those together. And then I factored out the e to the x minus 3. That let me find the critical value. Remember, that's never equal to 0 because it's an exponential function, right? And it's not shifted down. It's shifted right 3, but it's not shifted down. So that we don't even have to consider that. And we know it's always positive. So the only critical value is that x equals 2. So I drew my number line. I said, okay, if I'm less than 2, like 0, that's positive, and that's always positive. So the product will be positive. And if I'm greater than 2, this is negative times the positive is negative. So it's increasing negative infinity until 2. It's decreasing from 2 to infinity. And because the function is changing from an increasing function to a decreasing function, or the derivative changing from a positive to negative, I know that x equals 2, there's a maximum. Okay, so let's go back and I don't think we need to worry too much. I'm pretty sure I'm going to get this right. Decreasing, what did I say? Sorry. It'd be nice to have that other page up here, wouldn't it? Decreasing from negative infinity until 2, or no, it's increasing. Yeah, increasing, that's what I want. Increase from negative infinity until 2. And there's no, that's the only place it's increasing. And then it's decreasing from 2 to infinity. And there's a maximum at x equals 2. Bazinga. This one has a video. I want to listen to myself talk about this, okay? So I know it's a polynomial, so there's no places where it's undefined. I just care about zeros here. And what they're asking me to do here is use the second derivative test to check for maxes and minimums. And you're going to see why. Yeah, I don't want you to prejudice. Don't take my word for the only way this is here. Okay, just my opinion about the second derivative test. Sometimes, depending on what they give you, it's the only way to go. They'll be in. I might very well do that in the exam, is give you a table with these values. You're going to make those decisions. But in the practice test, you'll see that. I don't think I have one set up for week 7, but I will in the practice test. So anyway, so here's what I did. There's the function. I took the derivative, power rule. Then I said, boy, it'd be really nice to see if I could factor out. I set it equal to 0. So I said, it'd be really nice to, if everything's divisible by 18, so I can factor it out. And lo and behold, this is. So because 18 is just a stretch factor, I just divided it by 0. Remember, that doesn't change the zeros. And came up with that factors to this, and those are the zeros, right? Those are the critical values for the first derivative. So then I said, well, let's not even worry about the second derivative test. Let's do it this way. So I marked those critical values on my number line. And when I'm less than 3, these are both negative. So positive. Between 0 and 4, that one will be negative. So it's negative, and greater than 4, they're all positive. So this is going to be a maximum because the derivative is changing from a positive to a negative, and then from a negative to a positive makes it a minimum. Okay, so we know those are the answers. Let's do the second derivative test. So the second derivative, it's this derivative of the first derivative, right? So I brought down the 2, got 36x, subtracted 1. And then same deal, 126, 126. So then what you do is you're going to take those critical values for the first derivative, substitute them into the second derivative. So I did that. I didn't even finish calculating it because all I really care about determining is the function concave up or concave down at these points. Remember, if the second derivative is negative, it's concave down. And I didn't do this in a video, but I'm sure that you've seen it elsewhere. And I had a former calculus student from Oxbow head down at Smith College, and she had a great math student. Don't get me wrong, but the major she went in wasn't math sciencey, so she took calculus for poets. And I thought it was a funny thing. And her professor drew this in the board. I can't forget the negative and the positive. Okay, so when the second derivative is negative, it's concave down, frowny face. When the second derivative is positive, it's concave up. That's good, I guess, assuming that concave down is bad and concave up is good. I don't know. Sounds like a very creative way to think about it. So if that helps, hold on to that. So because the second derivative is negative, I know it's concave down. That makes it a maximum value. Okay, see how that's that turning point, but it's turning going down like that. And then for x equals 4, I dropped in 4 into the second derivative, and that turned to be positive. So that means it's concave up. That makes it a minimum. So see how that works? It's concave up, minimum. It's a turning point from the bottom, right? So that's what the second derivative test does for us. It's can be useful. I want you to think I don't appreciate it. I just, so let's see. Oh, do I really? Oh, let's see. Do I have this on paper? I do still. Let's see. So my second derivative is 18 x to the second minus 126 x plus 216. And then the second derivative is 36x minus 126. Okay. And we're going to evaluate g double prime of -3. Oh, look, they really even give us the, oh, they don't even make us do +4. Oh, okay. All right. Well, now you've seen both of them. So G is now, what do they want? They want a number. They want the actual answer. Oh, crap. Let's see. 108 minus 126 is -16, isn't it? No, it's negative. Yeah, -16. -16. So because the graph, let's see, at x2, the graph is concave up. Oh, no, it's concave down. That means there's a local maximum there. What? Just a minute, guys. I'm going to pause my video and see if I screwed up or if it's a problem that's broken. You probably didn't notice this. I thought this is embarrassing. What did I do here? I had the right problem written down, but for some reason, when I took that derivative, I wrote it as a negative, so I screwed up. Okay, so yes, I am wrong. I did that problem wrong incorrectly. So you probably won't see this unless you watch this whole video from end to end. So I won't jump to this, but so I'll go ahead and try it again. Okay, so this question does have a video, but I thought I'd record one anyways. So this is asking us to do the second derivative test. We're going to be asked to find the critical values of the first derivative, to test those into the second derivative and see if it's positive or negative, or see if it's concave up, concave down. So here's what I did. Here's the original function. I took the first derivative, power rule, did the second derivative, power rule. And then I asked myself, well, when's the first derivative equal to 0? Well, I noticed I could factor out at 24 out of everything, thank goodness, because that pulled those numbers down quite a bit. Set the derivative equal to 0. And then because the 24 is just a stretch factor, it doesn't affect the zeros, I got rid of it. I divided both sides by 0. And then so that factors nicely to this. So those are my two critical values. And then I decided, well, the first derivative test works really well too. So let's see what that did. So I wrote them down, and then I substituted a number less than 2 into my derivative, and it was actually probably went up back here. I guess I went here, and that's positive, so it's increasing. And then number between 2 and 4, well, let's see, that would have been positive, but that still would have been negative, so negative. And then greater than 4, positive. The other thing to keep in mind, I don't know if you made this connection yet, this is a parabola, and parabolas look like this, right? And they go through the x-axis. So left of that left critical value, the derivative will be positive. In between the two critical values, it'll be negative, and right of the last critical value will be positive. So you don't have to do the test if it's a parabola, if you've got that connection. Okay, so that's just something you can keep in mind. So I know because the derivative is changing from a positive to a negative, the function changed from an increasing function to a decreasing function. 2 is a maximum happens at 2. What that maximum is, I'd have to go back in and find it into the original function. And because the derivative is changing from a negative or a positive, or the function is changing from a decreasing function to an increasing function, it's a minimum at x equals 4. But there, it asked me to do that. They want me to use the second derivative test. So how does that all work? Well, let's see. So here's what the second derivative test is. Now, I haven't spoken with you about this. I don't know if the videos you've come across has. The story I have behind this, I had a calculus student from Oxford to go down to Smith College, and she didn't go. She had to take calculus. She did very well, passed the AP test, did really well with me. Went to Smith, did a non-scientific major, got to take calculus for poets. I don't know why. I guess Smith was being snooty and didn't want the AP score. That was back before I could offer dual enrollment for the same course. So she took calculus for poets, and her professor told her, drew this smiley face up on the board and said, when the second derivative is positive, it's concave, the function is concave up. So the second derivative is positive, the function is concave up. When the second derivative is negative, it's concave down. And then if it's concave up, it's a minimum. If it's concave down, it's a maximum. So maybe that'll help you remember that. Katie came back and was very glad to show me that. And then so G prime of 2, I dropped 2 because that's that first critical value. Well, that's a negative number. That means the function's concave down. It's going to be a maximum. Of course, that's what we came up with here using the first derivative test. And then I dropped in 4. It's positive. That means the function's concave up, and that makes it a minimum. And of course, that's what we got at using the first derivative test. So that's the findings that I came here. Let's go see if I can get the MyOpenMath question right. So the first derivative is here. Let me get my paper out of my scanner. First derivative is 24x to the second minus 144x plus 192. Then they're having us do the second derivative right off the bat. So that's 48x minus 144. And I get these signs right, don't I? Yeah. So then we're going to evaluate it at 4. The second derivative at 4. Oh, they actually want the number. Oh, crap. Let's see. 196. No. 48 is 96. So is it 198? 198 minus 144 is 54. I don't really want to get this wrong. I'm going to do this on a calculator. 48 times 4 minus 144. Yeah, 148. I think that's what I said. So it is positive. So that means the graph is concave up, which means it's a minimum value. Oh, be right this time. Second time I've done this problem. That's because I copied the sign wrong. All right, so hopefully that helps. It explains the whole process and lets you go on with this. Just so you know, this is a, see how this submit part, this is a multi-part question. And then I'll walk you through it just like what we did before. So you'll want to take the first derivative, find the critical values, submit those, then I'll walk you through it. They're just doing the same second derivative test. So I don't think I need to talk you through the math. It's just that's how you answer this question. I don't know if you watch my videos about the about using the second derivative test first. I got very long and I got tired. I don't know how good they were. I'll try this one here. Does this have a video associated with this? It's not, so this is probably worth doing. So this question's asking us to, use some calculus to graph this this rational function. Okay. Honestly, a lot of it we don't need calculus for, but it's nice to verify what we're seeing. Okay, and it'll help give some practice with the calculus. So we're going to do the x-y intercepts, the vertical asymptote, horizontal asymptote. There's one, and inflection points, if any, and I didn't do a return, any turning point. So on this problem, that's bad formatting. I modified this, so this is my fault. I got to fix that. Go fix that. Didn't notice that. Anyway, so here's what I did. I said, okay, let's use some pre-calculus. I said, I know it's the same power, right? X to the first over the x to the first. So way out infinity, the limit as x approaches negative and positive infinity will be 1/4. So in both cases. And then the x-intercept. So I guess I did some calculus there. And the x-intercept is where the numerator is equal to 0, so that happens at -4. The vertical asymptotes happen where the denominator is equal to 0, so that's going to be -1/4. And then the y-intercept, x equals 0, so that gives me 4. So I knew those points, and I could have done a lot of it with that. Actually, if you come down and take a look at it, I put in the horizontal asymptotes, I put in the vertical asymptotes, I put in the x-intercepts. I graphed it like that. It's probably all I need to do, but let's verify it. So unfortunately, it's a quotient. No easy way to do this derivative, so I did the quotient rule. And it came up with that. Now, some things I noticed were that the numerator, besides the -1/4, which isn't part of the function, so I can't include that, talk about that being a it's a critical value, but either side of it, it's because it's always positive on the denominator. That makes the derivative always negative. So that means it's always decreasing. And then I did the second derivative. So what I did is I rewrote it as a power. So I didn't have to do the quotient rule here. And of course, you brought the -2 down and took away one more, and then times the chain rule. So that gave me this. So I did have the critical value. The vertical asymptote is the critical value. So left of -1/4, so like at -10, that'll be negative cubed, which is still negative. So I'll make the second derivative negative, telling me that's concave down. And to the right of -1/4, like 0 is going to be positive. So that tells me it's concave up. And that confirms what I saw, what I drew and what I saw. Now, there's no turning points. Because there's no critical, there's no maxes or mins, because the second derivative is always, first derivative is always negative. So I've answered all those questions, and then I just graphed it, and I already graphed it already. So what's tricky about it, I've had you do a little bit of graphing. What's tricky with graphing these things, let's see, I honestly don't know how to graph this. Let's see. What do I want? Would it let me do lines? Really? Is it all let me do lines? Oh, this is a broken question, folks. if it won't let me do, if it won't let me do a parabolas, oh yeah, then this is a broken question. So don't worry about graphing it. If you want to throw it on paper and send it to me again, make sure you know how to do that. I didn't realize that. Isn't that awful? So the next one does the same kind of thing then, just a little bit. Now this has, does this have a, no, see, this just has, well, we could do the oblique asymptote. So I guess I'll do that just so you can, just so, but boy, it's too bad that this happened like this. I didn't realize he did this. Right? No, they aren't letting me do much with that, are they? No. All right. All right. I'll go ahead and do this and you can, so don't worry about doing the graphing on MyOpenMath for this, but I'll come through and do the math for this. Okay, so I don't remember where I left, so I'm gonna run the process on this. And honestly, I haven't crafted on Desmos yet, so I probably should, so I don't have to redo this video, but we'll take it cold. So here's it. Things I noticed, this is a top heavy function, so I know there's an oblique asymptote, right? A slant asymptote. So what I did was, here's my work. Some things, I did some pre-calculus first. I backed the numerator. I knew so that tells me there's x-intercepts at -2 and at +1, and the vertical asymptote in half is at 4. And then plugging in 0, you get a y-intercept of 1/2, right? And then I wanted to find that slant asymptote, so I did the long division with it. And that's where, I think I opened this up in a better picture here. Yeah, bigger picture here. So I did the long division on it. And that gave me, there's the slant asymptote and the remainder and everything. And then, of course, then they wanted me to do, what did I do here? Why did this? That would just undo what I just did. All right, pretend I didn't do that. I think I figured that out eventually. Sorry. Yeah. And so I took this form and I found the first derivative. So 1 and 0, and then treated it like 18 times x minus 4 to the -1, brought the negative down in front and squared it, right? But then I needed to, pretty easy to find the derivative there, right? But because I needed to analyze it, do the critical values, crap, am I recording? Yes, I am, but I don't know if you can hear me because I got the wrong mic on. Trouble with having two headsets. Hopefully this is loud enough. It's a pretty good mic I've got on the other one, so it probably picked up most of what I said. All right. So anyways, I made this want to be one fraction, so I multiplied this by the x minus 4 squared, and then I guess I FOILed it out, didn't I? Now the issue is I could have extracted the square roots. Of course, the trouble with this is this doesn't factor. So I went with a quadratic formula. The reason I knew it didn't factor because I used the discriminant and I saw that it came up to be 72. And so that's not a square. So I know it's not factorable. So I just slapped that into the b squared minus 4ac and then negative b over 2a. And that didn't copy through, did it? Oh, just a minute here. All right, well, so then I went 8 minus 6. Actually, I think what I did is I wrote it as 4 because it's over 2, right? So I divided it and made it 4 plus or minus 3 square roots of 2. Not that it matters, but I just went to a decimal anyways. So then I did 4 minus 3 square roots of 2, got that. I did 4 plus 3 square roots of 2 and got that. And then what are the critical values? Well, those 2 zeros and the vertical asymptote, and then I substituted yeah, I went back to that unfactored form. I just substituted in negative. I said negative 10 and it came up to be a positive number because it's 100, right? You see my thinking there. And then 0 would be in between. That was negative, and 5, it was negative also. And then 10, it was positive. So functions increasing, then decreasing, then it jumps over the vertical asymptote, and then it's back to decreasing, then increasing. So I know there's going to be a minimum, a maximum at that critical value. So there's a turning point, and then there's a minimum at that value. So there's another turning point. So then I was checking on concavity. So I took the second derivative. I went back to this. And I said, what's the derivative of this? Well, that's 0. And I wrote that as negative 18 times x minus 4 to the negative second, and then brought the negative 2 in front, which gets where I got the 36 from. Oh, wait a minute, where did I do that? Oh, I didn't get 36. I got 18. Ha, I guess I did that wrong. Oh, isn't that funny? However, because the numerator, it doesn't really matter. If they were looking me to type it in, I would get it wrong. But however, it still would be a positive 36, right? So if I'm testing for the concavity, that will be if x is less than 4. That's funny, I made that mistake. If x is less than 4, it'll be a negative number. 36 divided by that will be negative concave down, and greater than 4, it'll be positive, so concave up. So I'm okay there. And then I knew I had to figure out those maximums and minimums. So, well, actually, honestly, the first thing I did is I sketched in the vertical asymptote. I sketched in the slant asymptote. I marked in my 2 x-intercepts. I marked in my y-intercept, right? Something that's hard to see in this graph is the maximum minimums, okay? Because it's so close. So but what I actually did is I substituted that into the original function, got that for the y. So that's where the max happens, which you see that's not too far from the 0.5. So then you can see where I graphed, that was an error. I wasn't paying attention that it's over at 8.2. I was thinking it was close to the vertical asymptote. So that's where that maximum, where actually it's a minimum, isn't it? But it's a lower turning point. And then, so this part was fairly easy to graph because I knew it had to follow that, come down to that vertical asymptote, pass through that point, pass through that point, pass through that maximum, pass through that other x-intercept, then head down towards that horizontal or that slant asymptote. And then the only numbers I really had for this one was that minimum value. So I knew I had to come down. I probably should have made that look a little better. Okay, so that's what I think it is by hand. Let's see, I'm going to stop it, go open up Desmos and see what it looks like.